Welcome, scholars. We are so glad that you have joined us today. During this show, we are going to support you in navigating word problems through reasoning to help you continue to be the wonderful mathematicians that we know you are. From number sense to algebra, we've got it all covered. So let's get started.
4, 3, 2, 1.
Good afternoon, boys and girls. Coach Brenner here. We're going to be looking at some 4th grade material today in terms of division, where we have to interpret remainders. We've all been in that position where we want to make sure that we have enough of something, whether it's enough cars in a caravan to get somewhere, whether we have enough seats on the bus if we're going on a field trip. In today's problem, we need to make sure we have enough tables with chairs in order to seat everybody. Okay, so these are some real world types of questions, real world examples that really you can use them in our everyday lives. So today we're going to look at a division problem. We're going to make sure that we can interpret the remainder in order to solve the question. So stay tuned. Remember, we need to make sure that we're participating at home, because we want to hear from you at some point as well. All right, so stay tuned. We're going to get through this mini lesson on division right in a moment. All right, so let's look at what we're working with today. So 4th graders, by the end of today's lesson, we're going to be able to solve those multi-step word problems posed with whole numbers and having whole number answers using 4 operations, including a problem with remainders that must be interpreted. So let's look at the question we have here. Before the question, we're going to look at this 3-read protocol because it's going to really help us solve this problem. And you've used this in your classrooms throughout the school year. So our first read, what's the situation about? Our second read, we're going to ask ourselves, what are the quantities in the situation? And in our third read, what mathematical questions can we ask about the situation? So within this 3-read, we're going through the problem, we're breaking it down, and we're setting ourselves up to be successful and be able to get to the correct answer. So our problem, there are 32 students in a classroom at Sequoia School. Each table in the class fits 6 students. How many tables will be needed? So here's our table. This is our first read. What's the situation about? Well, this situation is about tables and making sure that we have enough of them, because we know that 6 students can sit at each one. All right, so let's move to our second read. So our second read, what are the quantities in this situation? There are 32 students in a classroom at Sequoia School. Each table in the class fits 6 students. How many tables will be needed? What are the quantities, which are those numbers in this situation? The quantities are 32 students, and we know that each table fits 6 students. So these are the quantities that we're going to need in our problem to solve it. The units that we're dealing with in this problem are the students connected to 32 and the students connected to 6. So 32 is our quantities, students are our units, and 6 are our quantities, and students are our units. All right, so our third read. What mathematical questions can we ask about this particular situation? So this is where you put your thinking caps on. You try to come up with some questions that might go into the statement itself? Do all the tables need to be full? Can we have tables that aren't filled up? And are they the same size tables? Now, some of these questions may be something that we can actually use, and some of them, like the same size tables, that doesn't necessarily matter, but it's to get your students thinking and get their brains moving. All right, so now let's actually go into solving the problem. All right, so what type of problem are we going to have here? Well, we know that we have 32 students and we need to fit 6 students at each table. So we're going to have a division problem here. So the division that we're going to do is we're going to do 32 divided by 6. Now, how many groups of 6 can go in to 32? So on my side, I'm counting by 6s, right? So I have 6, 12, 18, 24, 30, 36. 36 is too much, so I can see here that I have 1 group, 2, 3, 4, 5 groups of 6, and my 5 groups of 6 total 30. And my next step here is I know I need to subtract. And if I have 2 left, which is actually those 2 students, can I make another full table with that 6? Nope. So I have a remainder of 2. Now, let's see how this remainder of 2 affects our solution. All right, so let's revisit this problem. There are 32 students in a classroom at Sequoia School. Each table in the class fits 6 students. How many tables will be needed? So from our drawings, we know that for one table, there are 6 students. A second table, 6 students. Third table, 6 students. Fourth table, 6 students. Fifth table, 6 students. Do we need another table? Well, I know that there are 32 students in the class, and with these tables, we only have 30 students. So, how many more students need a seat? Well, if you said 2, that's correct. We have 2 more students that need a seat. So, do we need another table? Let me think. Well, we sure do. So, we have 2 students at our last table. So, how many tables did we need? That's what we're thinking about to solve. We know that we have our 32 students seated. So, 5 tables times the 6 students equal 30 students. Then we had 1 table for 2 students, right? So then we ended up with the 30 students plus the 2, which we got 32 students. So if we look at it, we count our 5 tables that are full and our 1 table with 2 students. So we would need 6 tables to fit all 32 students. Well, first, I want to thank you guys for tuning in today on our Count on Us mini lesson. I think it's really good when you can be able to see how math can be incorporated into your everyday life. In terms of division, with interpreting remainders, you really can use this strategy in everyday life, whether you're going to a sports game, you're having a birthday party, some type of occasion at your house other than that. In this instance, we need to make sure that we have enough chairs. So at a birthday party, you want to make sure that you have enough seats for all of your friends and family. If you're going to a sports game, say you meet up with your teammates and you guys are all jumping in different vans or different vehicles, you want to make sure that you have enough seats to hold everybody. Your teachers actually have to do this every time that they schedule a field trip. Think about it. With field trips, you have students you have chaperones, you have the teachers that are also accompanying them. So those are some problems that you might have actually worked on throughout this school year. In terms of the field trips, you need to make sure that you get enough buses for everybody that's participating, but you also don't want to go over and you have a bus that you don't need. It's like, for instance, in this problem, if we had 7 tables and 6 people could sit at a table with those chairs, would we need the 7th table? No. But if they extended the problem and they said 6 people don't have to sit at each table, and there could be 3 or 4 students, or even 5, depending on how they wanted to sit, how many tables could we have? So depending on the question itself, depends on the answer that you need. Thanks for tuning in today. Coach Brenner here for 4th grade. Count on us, where we worked on division and we interpreted the remainders. Stay tuned. 5th grade is up next. I know that if you're in 4th grade and you watch this, watch the 5th grade one. See what you can do with those types of problems, because next school year is going to be here before you know it. All right, see you guys next time. And remember, you can always count on us.
Hello, and welcome to another episode of Count on Us, Reasoning and Problem Solving. I am Coach Twitty, and I am so excited to share this math problem with you today, where we will add, subtract, and multiply decimals. So let's get ready to do some math. All right, so our problem today, we're going to work together. I'm going to use an online platform because I really want to show you how to use the tools available. It's totally fine. Grab a piece of paper and a pencil and work with me. All right. Do you have your paper and pencil? Let's get ready to do some math. So here's our problem for today. The first time, I'm just going to read the problem and begin to think about, well, what is this problem really telling me? So Katie went to the craft store to purchase the supplies she needs to make 2 types of jewelry. This table shows the cost of supplies Katie needed. Cost of supplies: beads, 5 cents, charm, 45 cents. This table shows the supplies needed to make each piece of jewelry. Bracelet, 25 beads, 4 charms. A necklace, she needs 48 beads and 1 charm. Katie purchased the exact amount of supplies to make 1 bracelet and 2 necklaces. All right, you all, that was a lot of information. What is the problem telling you? Okay, Katie's going to make some jewelry, and to make a bracelet, she needs 25 beads, and each bead costs 5 cents. And to make she also needs 4 charms to make a bracelet, and each charm costs 45 cents. To make a necklace, she needs 48 beads at 5 cents a bead, and 1 charm at 45 cents per charm. And she purchased the exact amount of supplies to make 1 bracelet and 2 necklaces. All right, do we have that information? Great. Let's get ready to do some math. So part A. Automatically, if there's a part A, I have to make sure I look and see if there's a part B.
Here's
and
my
a part
graph
C
I've
and a
been
part
using
D.
to track my
Keep
gas
that in
usage.
mind. Write an expression to determine the
Do
cost
you
of
think
supplies
the
to
graph
make 1
represents a
bracelet.
proportional
So
relationship
this question is
between
only
the
asking me
distance
to
and gas
write an
usage?
expression. It has not yet asked me
I
to
really
solve
don't
it.
know.
To create
Well,
my expression, I'm
I
going to
think we
use
need to
something
look
that
at the
we
math.
learned in class, some parentheses.
Let's zoom
So
in
first,
on the
I'm going to
graph.
click right here on my parentheses. And then
the
if I
points
click
on a
right
straight
on
line
that
go
box,
through the origin,
it's going to
the
close
graph
out my
represents
parentheses.
a
So this
proportional
lets me know the
relationship.
first thing that I
That's
need to
one
do
way to check for
is
proportionality.
figure out what does she
But
need
let's
to make a
conduct one
bracelet.
more
Well,
check
it tells me
just
right
to make sure
here
there's a proportional relationship
that she needs
between the
25
distance and
beads.
gas usage.
And so how would I write that as a
Now
mathematical
let's check the
problem?
points on the graph.
25 beads.
Grab
And
some
how much
scratch
is each
paper.
bead? Times,
We're
and I
going
can
to
hit
write
the
down
times
the
button right
coordinates
here.
for each
5
point from the
cents.
graph. Are you ready?
And
All
don't
right.
forget to label.
Let's begin. My car travels 20 miles
Next,
on
I
1
want
gallon
to
of gas.
add the
40
cost
miles
of
on 2
the
gallons of
charm
gas.
because she needs a charm
and 60
as well.
miles on 3 gallons
Okay,
of
so I'm
gas.
going to add my parentheses back in here. And remember, I'm just going to hit the parentheses
when X
button.
is 1
And then if
and
I
Y is
click
20,
right here,
this is
it
your
allows me
constant
to
of
close my
proportionality,
parentheses.
K.
Okay, so
If
the
we look
cost
at
of the
the unit
charm, I have
weight,
4 charms,
looking
and I'm
at
going to
amount
multiply.
of
It
gas
says the
used
time sign.
compared to the
45
distance
cents.
driven in
25
miles.
beads at 5 cents. I have that from right here. And
So
4
we've just found
charms
out that I
at
can
45
drive
cents.
20 miles
That's my
per gallon.
expression for the cost
So
of
let's
the
check the
bracelet.
other ratios
Let's look at
for
part B.
proportionality.
Have to scroll down.
Create a table of
So
values
part
on
B
your paper
asked me,
using the
write an
coordinate
expression
pairs.
to
Do you
determine
see a
the cost
pattern?
of supplies to make 2 necklaces. Well, let me look over here. 2 necklaces is right here.
Now divide
48
the number of miles
beads and
by the
1
gallons
charm.
of gas.
So there's a lot of
table.
different ways that we could
What's
do
the
this to
value of the
create
second
the
and
expression.
third ratios?
Well, there's
We know the
we
first
could multiply
ratio
them first.
is
We
20
could
miles
add
per
them
gallon.
together. What do you think we should
Go
do?
ahead.
I
I'll give you
agree.
time to try.
So we're going to start
On
with
your
our
own.
parentheses again. This time we're going to put 2
You're
sets
right.
of parentheses, and you'll
The
see
second
why
ratio
later.
on the table, 40
So in the first set,
miles
we're going to
divided by 2
say,
gallons
okay, so the
equals
necklace,
20 miles per
I
gallon.
need 45 beads,
The third
and each
ratio,
bead costs 5
60
cents.
miles
I'm
divided
sorry, I
by
need
3
48.
gallons
So
of
48,
gas
I'm going
is
to
equivalent to 20 miles per gallon.
multiply.
We have
5
equivalent
cents.
ratios. So we can say the graph represents a proportional
And then I'm going
relationship.
to add that.
Remember at the beginning
So I'm
of the
gonna use
lesson,
the addition
I was at
symbol.
the gas station and I pumped 5.5 gallons of gas into my gas tank.
To 1 charm,
Now I need to figure out how far can I travel
and
in my
that's
car on
times
5.5 gallons of gas.
45 cents.
I think I'm going to use the graph.
And then I'm going to multiply this whole thing
First,
times
I need to figure
2.
out the location of 5.5 miles on the x-axis. I'm going to use estimation. So
Okay, so there I have 48 times 5 cents
location of 5
plus
gallons of gas
1
and 6 gallons
times
of gas.
45 cents.
And
And I'm going to
halfway,
multiply all
I
of that
drew a
times
vertical line.
2 because she
Let's
made
see
2
what
necklaces.
location on the
It is
y-axis
yet to ask me
corresponds with
to
5.5
solve
gallons of
any
gas
of the problems.
on
So
the
make sure that
x-axis.
you're really reading for what the question is asking.
5.5.
And
110.
always remember to keep scrolling down to make
So
sure that
my
you
car
answer
travels
every
110
single
miles
part
on
because
5.5
this question
gallons of
has
gas.
3 parts.
Let's double check
Katie
the 2 ratios for proportionality. I'm going
Started
to find a
with
quotient of 20 divided by
$40.
1
How much did
and see
she
if it's
have
equivalent
left
to
after purchasing the
110
supplies?
divided by
Enter your
5.5.
answer in the space provided. Enter only
They're
your
equal.
answer. So I'm only writing
Those
my answer in this
ratios are
space right here.
Equivalent.
Okay, so let's go back up here to my equation.
To review
And for
today's
these purposes,
lesson,
Ms.
I've
Twitty is going
created
to
a
use
proportional
some
checklist.
space over here
let's
to
get
solve my
started.
problem. It'll be like my scratch paper.
Number 1.
So my
check
first
to see
problem
if the
was I
graph is
needed
a
the
straight line
expression
that passes
for
through
the
origin, 0,
bracelet.
0.
So we said
Number
that the
2.
bracelet had
Identify
25
the coordinates
beads,
for each
and I'm
point
going to
on the graph.
multiply that times 5 cents.
Number 3. Divide the
All
y
right, so
coordinate
here we go
by
to
the
multiply my
x
decimals.
coordinate
I'm going to
to
multiply
check
5
for
times
fitting
5,
ratios.
and that's 25. Miss Twitty's just going to use the standard algorithm. And then 5 times 2 is 10, plus
That's
2
it for
is
7th
12.
grade today.
I know that
The
there
next
are
segment
2
will be for
places to
8th
the
grade
right of my
students.
decimal in the
See you
problem.
next time.
So I need to put 2 places to the right of my decimal here, and that gives me $1.25. So I'll just keep this running tally over here for each piece. $1.25. The next part was to figure out the cost of the necklaces. Oh, nope, wait, Miss Twitty's wrong. You have to go back and figure out the cost of the charms for the bracelet. So that is 45 cents times 4. So 4 times 5 is 20. I'm going to put my 0 there and my 2. And then 4 times 4 is 16, plus 2 is 18. There are 2 decimals in my problem, so there needs to be 2 decimals in my product. So my answer is $1.80. So I'm going to add that over here. And just to make it a little simpler, I'll go ahead and add these up. So that's 5 plus 0 is 5. 8 plus 2 is 10. And then my 1 plus 1 plus 1 is 3. So right now she spent $3.05 on the bracelet. Now let's see, how much did she spend on the necklace? And remember, we talked about there were a lot of different ways that we could work on the necklace piece. So Miss Twitty is going to start by just simply multiplying 48 beads times 5 cents. So 48 beads times 5 cents. So 8 times 5 is 40, my 0 and my 4. 5 times 4 is 20 plus 4 is 24. Remember, once again, if there are 2 spaces to the right of the decimal in the problem, I need to make sure the same happens in my product. And so my total for one necklace is $2.40. But remember, there are 2 necklaces. So then I need to take $2.40 plus $2.40. And so that gives me 4 plus 4 is 8. 2 plus 2 is 4. So $4.80 for the beads for the 2 necklaces. So let me add that over here. So that's 5 plus 0 is 5. 0 plus 8 is 8. And 3 plus 4 is 7. All right, one more piece and then we can add them all up. So our last piece is to find out how much the charms cost for the necklace. So each charm is 45 cents and I have 2 charms. So if one charm is 45 cents, I can just add the cost of my second charm, 45 cents, to that. So 45 and 45, 5 and 5 is 10. 4 plus 4 is 8, plus 1 is 9. So the cost of the charms for the necklace is 90 cents. All right, are you all following along with me? Okay, so here we go. We're going to add these last few up. So this is 5, 9 plus 8. Ooh, that's a hard one. But if I take 1 from that 8, that'll be 10 plus 7. I can do that. 17. And then 1 plus 7 is 8. So $8.75 is how much Katie spent on bracelets. However, it did say they wanted an exact amount. It says to enter the exact answer only, and she had $40. So my last step is $40 minus $8, because this is how much she spent, and 75 cents. All right, it's a lot of subtracting across zeros now. This will become a 3, and I'm going to regroup here. I will do the same thing here and regroup over here. And then I have one more time to regroup, which would be right here. Now I think I'm ready to subtract. So 10 minus 5 would give me 5. 9 minus 7 is 2. 9 minus 8 is 1. And 3 minus 0 is 3. And I need to make sure that I align my decimal point right there. And so in total, Katie had $31.25. Fabulous. Well, that is our show for today. It was really great seeing you today. In 5th grade, we worked on adding, subtracting, and multiplying decimals. We look forward to seeing you next week. And remember, you can always count on us.
Welcome to Count on Us, Reasoning and Problem Solving, Math 6 edition. My name is Coach Lewis, and I will be assisting you with becoming a successful mathematician. Today we will be looking at Standard 6, NS7. Your goal for today is, I can explain how to use the number line to compare integers. Now let's get started. Our problem for today has two parts. Part A reads, plot the location of -2 and -9 on the number line. Let's take a look at the number line. In the middle is 0. To the left of 0 is -10, and to the right of 0 is +10. This means that to the left of 0 we have negative numbers, and to the right of 0 we have positive numbers. Now, since -2 and -9 are both negative numbers, their locations on the number line will be to the left of 0. So let's plot -2. -2 is 2 units left of 0. Now let's plot -9. -9 is 9 units to the left of 0. Wow, we have satisfied part A. Now let's look at part B. Part B says, use mathematic symbols to write an inequality that compares -2 and -9. Explain how the number line can be used to show that your inequality is correct. Let's look at what this is asking us to do. I'm going to underline some important words that will help me. So, we're going to write an inequality. To determine which inequality symbol to use, we need to think about which number is greater, -2 or -9. Which number do you think is greater? Excellent. -2 is greater than -9, so we will use the greater than symbol. Now the next part of this problem is to explain how the number line shows that the inequality is correct. Well, we know that the number that's closest to 0 is going to be the larger number, and -2 is closer to 0. Therefore, it is the larger number. Our second problem for today deals with temperatures. Let's read the problem together. Are you ready? Let's go. The lowest temperature ever recorded on Earth was -89 degrees Celsius in Antarctica. The average temperature on Mars is about -65 degrees Celsius. Which is warmer, the coldest temperature on Earth or the average temperature on Mars? Explain. Write an inequality that matches your answer. There are two things we need to do in order to completely answer our problem. First, we need to answer the question, which is warmer, the coldest temperature on Earth or the average temperature on Mars, and we have to explain. Well, thinking about negative numbers, I know that the number that will be closest to 0 on a number line is the largest. And if I relate this to temperatures on a thermometer, the negative temperature that is closest to 0 will be the warmer temperature. Remember, a thermometer is an example of a vertical number line. Now, of course, we know that when the temperatures are above 0, those represent warmer temperatures because the number is positive. And when the temperature is below 0, those temperatures are colder because the numbers are negative. Okay. So where would we plot -89 and -65 on a number line? Do you know? That's it. -65 is between -60 and -70. And -89 is very close to -90 on the number line. So which number is closer to 0? Based on our number line, negative 65 is closer, which means that the average temperature on Mars is warmer. Now let's write an inequality to match our answer. That's the second thing that we have to do. Okay, now what symbol would I have to put? Negative 89, I know that that number is smaller than negative 65. Okay, so then I will put a less than symbol because negative 89 is less than negative 65. Or I can write it another way and put the greater than symbol. Negative 65 is greater than negative 89. In our previous problem, we looked at lowest recorded and average temperature on Earth and Mars. Now let's extend that problem a little further. The diagram shows the planets of our solar system and their mean temperatures in degrees Celsius. Carrie says the mean temperature on Jupiter is greater than the mean temperature on Mars because negative 110 is the larger number. Explain why Carrie's reasoning is incorrect. Remember what we discussed about number lines? The negative number that is closer to 0 will be the larger number. So looking at the mean temperature on Mars, which is negative 65, and Jupiter, which is negative 110, let's decide which one is closer to 0. That's right, negative 65 is closer to 0. Carrie thought that Jupiter's temperature is greater because he must have just looked at the number itself, 110, without considering the negative sign in front of it. Because actually, negative 110 is less than negative 65. And we can see that on our number line. Even when we put the numbers in order from coldest to warmest, we still see that Mars is close to 0 and the positive numbers. Let's put them in order. We have Neptune, which is negative 200. Now we're putting these numbers in order from coldest to warmest. So our coldest temperature is Neptune, negative 200. Then Uranus is negative 195. Saturn is negative 140. Jupiter is negative 110. Mars is negative 65. Earth is 15. Now we're getting into the positive numbers. Mercury is 167. And Venus is 464. So we just put the numbers in order from coldest to warmest. This further shows Carrie's reasoning was incorrect because Mars, which is negative 65, is still closer to Earth, which is the positive numbers, which means it is closer to 0. Let's revisit our goal for today. Our goal was, I can explain how to use the number line to compare integers. How did we accomplish this? You said it. We started out comparing negative 2 and negative 9. Then we compared temperatures on Earth, Mars, and Jupiter. We learned today that a number line can assist us with comparing numbers because the closer a negative number is to 0, the larger the number. Congratulations! That's our show for 6th grade today. 7th grade will be coming up next, so stay tuned. And remember, you can always count on us.
Welcome back to another Count on Us with Partnering with Parents. I'm Coach Brenner, and today what we're going to do is we're going to talk about some things you can do at home to make sure that your students are prepared, whether they are continuing at home distance learning or if they're beginning to start in-person learning in the classroom. Some of these things, just to make it easier on you as the parent when these changes are taking place, and also these changes for students, since it's been almost a year or over a year since students have been back in the buildings. So throughout this episode, we're going to be talking about some of these different things that you can do at home to make sure that your child is as ready and prepared as possible when they go back in the buildings, or if they're continuing with distance learning at home. The resources that all students have, whether they're at home or they are inside the classroom, and they've been using this year as well, are some different resources through Clever. Now, in order for your child to sign in through Clever, they just have to sign in with their ID and their password, just as they would log on to their Chromebook or their email. Just as your students have been using possibly anything from Google Classroom this year, or to anything else that your child's teacher has asked them to sign on to. So in Clever, there's a bunch of different resources that are paid for by the county. One of them is Dreambox. Hopefully, if your schools have them and have distributed all the passwords and IDs, your children have been getting onto Dreambox. Dreambox is something that helps your child with on-grade level math standards to make sure they're staying where they need to within their own grade level. It also is challenging, and it's kind of just fun in some games. There's some other different apps down here. We know our Big Ideas that connects to some different textbooks. We're not necessarily using that right now, but for the older students that are those 6th, 7th, and 8th graders that have Big Ideas Learning, they can use that. Now, to K through 5, they're in Envision, so don't worry too much about that. IXL, that's another site that your students can practice different math problems. It's connected to standards as well. And these are just some things that your students can do at home. Now, one of the main things that students have been using this year in K through 5 for their online resources and tools is Braining Camp. Okay, and we're going to take a look at Braining Camp just to show you some of the different online tools that your students can use when solving math problems. Braining Camp is one of the apps that has been embedded into most of the activities that your students have been doing online this school year during distance learning. It's something that's going to be embedded in the activities and tasks that your students are doing the rest of the school year as well. Now, K through 2, we know that the majorities these are still going to be useful to them, and we know 3 through 5, some of the other ones such as algebra tiles, coordinate board, but these are all different resources for students to use. Now, one of the main things to build that fluency and understanding for students is using base 10 blocks. So we'll just take a look at it. We'll click on it. With the base 10 blocks, say students are adding a 3-digit number. Let's say the number is going to be 243 plus 325. We can put that text right there, and we know that that is something that they're adding. We literally can make 243 1 2 3 4, and then here, if we wanted to do 325 down here, we can move these down. And the cool thing with this is really giving your students an opportunity to kind of just check their work, because down here at the bottom, it'll tell the total. Now, if they click that I, it'll take it away. But if they really want to just check to see if they did their work right, say they're doing their work in a notebook, or they're doing their work in Pear Deck, This is just an option for them to come and check their work to make sure that it is correct. So this is how, and there's a lot of different ways that they can use this. There's decimals. So those 4th and 5th graders with tenths and hundredths, they can use that as well. So this is one of those concrete models that really help support student understanding in terms of math. Now, back here, for the younger students, we have the tiles, there's Cuisenaire rods, geoboards, hundreds board. There's just a lot of different things that students can use in order to help support their learning. So as a parent, check some of these out. Ask your students to show them, your child to show you how to utilize these so that you can get familiar with them as well. And if you have a little bit of time, you can log in through Clever with your student ID, your student's ID, and you can actually go through and check some of these out. So one of the organizational strategies that we've been working with students actually over the last couple years is the 3-read protocol. So it's important for you as a parent to understand how your child should be using this when they're solving math word problems. This is an organizational tool for students to kind of just get the problem started. So in a 3-read protocol, if you hear a teacher talking about this or your child mentioning this, this is how it's set up. So with a 3-read, the first read, students reading the problem. So what's going on in the actual problem? So they're just reading the problem as it is. The second read, what are the quantities? So what are the units? So they start pulling the units out of that particular problem. And then when they read the problem the third time, they actually come up with some math questions they can ask based on the information. Now, when teachers... All right, so let's look at this example. It's titled Books, and we're doing that 3-read. So the first read, we're going to read through the information and break down. So at first, we have Miss Smith's class library has 423 books. 50 books were borrowed by students. Okay, so we know that this is math, and we're doing something. We're going to be either adding on or taking away. So we're reading through to understand the first 2 sentences. Notice there's no question yet. Second, we'll pull out the quantities and the units. The quantities are the numbers. The units are what's connected to those numbers. So the quantity, 423, the units are books. In the second sentence, 50 books, the 50 are the quantities and the books are the units. So third read, we'll read through it and we'll pick possibly a question that we could answer. Miss Smith's class library had 423 books. 50 books were borrowed by students. So a possible question could be, how many books are left if the 50 books are borrowed? So let's see what a possible question could be. How many books were left in the classroom library? So being able to come up with that question allows the students to realize what they might have to do when solving for the problem. Thank you guys for tuning in to another episode of Partnering with Parents. Today, we looked at some of those online resources that your child is using at home or in school. These are some different ways that they're learning how to do math on their computer. This is also some different ways that you can help support them going through some of those online tools, learning how to use the base 10 blocks or color tiles or the geoboards. Those are just some things that you can do. We know you don't have a lot of free time, but in your free time, your child can show you how to use some of these tools. We also went through a strategy that your child's using in their math classroom, which is the 3-read protocol. In these 3-read protocols, students are breaking down word problems. It's important for students to show their comprehension in terms of what the question's asking them, to grasp the understanding so that when they're solving it, they know exactly what they need to do when getting to that final answer. Thanks for tuning in for another episode. We look to see you guys in the future, partnering with parents episodes. I'm Coach Brenner. You guys have a great day.
4, 3, 2, 1.